Okay, this video is about some different types of or KSP problems or problems related to KSP. And this first one, I know it might not be hard, it might be kind of hard to see this at the beginning, but it's actually like a Q versus K type of problem. So basically, what this problem is asking, like if you pour some barium nitrate, 20 milliliters of it, and it's 0.10 molar in a beaker with 50 milliliters of sodium carbonate, would the precipitate barium carbonate form? All right, so it's a Q versus K. So basically, you know what your K is already. So what you're going to do is you're going to find the Q. So what we're going to do is we're going to write the expression for the precipitate that we need. And so the precipitate is barium carbonate. So we're just going to go barium carbonate. Remember, that would be a solid. And if it dissolves in water, it's going to break into barium ions plus carbonate ions. All right. Now, the thing is about this is that you could write a Q expression. So Q, remember solids aren't in the expression, would be equal to the concentration of barium and carbonate. Now, the thing is, now Q might not necessarily be at equilibrium. So what we have to do is find the molarity of these ions in this beaker after they're poured together. So molarity is the moles per liter. So what we know right now is we know how much barium we have. So we have 20 milliliters. So 20 milliliters of it. And the molarity of it is 0.10 moles over 1,000 milliliters. That's the molarity. And basically what that would do right there is that would tell you the molarity of it. And so if I do this, I get 2.00 e to the negative 3 moles of barium. But you're going to be pouring it, you're going to be mixing it together. And so we have to get the molarity once it's in this bigger volume here, because we're mixing 50 plus 20 equals 70. So we got to get the molarity of it in the new beaker, or the new thing wherever you're mixing it. And so we got to take this 2e to the negative 3 and we got to divide it by the liters. Well, 70 milliliters is 0.0700 liters. So we're going to divide that by 0.0700 liters. And we end up getting 2.90 e to the minus 2. That's going to be the molarity of it. That's for the barium. Okay, now we're just going to do the same thing for the carbonate. Okay, so now the sodium carbonate is 50 milliliters of 0.1 molar. So we've got 50 milliliters, and it is also 0.10 moles over 1,000 milliliters. And let's see here. That's going to equal 5.00 e to the negative 3 moles. Oh, actually, I should have just wanted two significant digits up here and here probably. So that's going to be 2.9. Okay. So 5.0 divided by the volume again will be 0.0700 liters. And you end up getting 7.1 e to the minus 2. 7.1 e to the negative 2 molar. Now, what we're going to do, once we know these molarities, we're going to plug them into this Q expression. Okay, so Q will be equal to 2.9 e to the negative 2 times 7.1 e to the negative 2, which equals 2.1 e to the minus 3. 2.1 e to the minus 3. Then I just write down which equals K SP, which equals 5.1 e to the minus 9. And now after I write that, I look at that and I say, does 2.1 e to the minus 3 equal 5.1 e to the minus 9? Well, of course it doesn't. So I put a a line through that, which means, hey, they don't equal each other. Q does not equal K. So now if you notice, Q is way too big. Q has to get smaller. And so for Q to get smaller, okay, so how do you make Q smaller? Well, we have to make these molarities smaller, which means we're going to shift to the left here. And by shifting to the left, it's going to make a solid. So yes, it would make a precipitate because it's going to shift left and produce, and then basically you're going to get some barium carbonate solid. Okay, that's how you would do that problem. So why don't you go to the next problem on your worksheet, which is this problem right here. Pause the video and see if you can do this problem on your own. Then you can check your answer with this video. All right, so will calcium sulfate precipitate at 50 milliliters is added. Okay, so it's just like the last problem. So basically we have our calcium sulfate solid, and if we write it, it's going to make calcium +2 plus sulfate -2 when it dissolves in water. And so it will end up doing a Q versus K again. So first of all, we got to find the molarity of the calcium ions. Well, anyway, there's 50 milliliters of the calcium ions, and it's in a 0.0010 moles for every 1,000 milliliters. Now, whenever you take a volume times its molarity this way, you always end up getting the moles, and so I get 5.0 e to the -5 moles. Then I'm going to divide that by the volume that we end up getting here. So we're adding 50 milliliters here and 50 milliliters. So that's going to be equal to 100 milliliters, which basically we need to change that to moles. So if we have, or liters, I mean, if we have 100 milliliters, we can move the decimal 3 spots, and we're going to get 0.100 liters. And so if we end up doing that math, if we take 5e to the -5, so 5e -5 divided by 0.1, we end up getting 5e to the -4. So that's going to be 5.0 e to the -4 molar. That's for the calcium. Now we'll do the same thing for the sulfate. And anyway, the sulfate, notice that it's the same volume, but it's a little bit different molarity. And so 50 milliliters, and then it's going to be 0.010 moles over 1,000 milliliters. And if you end up doing, let's see, that math, you get 5e to the -4. You're going to divide that by 0.100 liters, and you end up getting 5.0 e to the -3. All right, so now we know our molarities in the solution of the calcium and the sulfate. So now we'll just do a Q versus K. So Q, remember, would equal calcium times the sulfate. And so we just solve for Q. So Q is going to equal 5.0 e to the -4 times 5.0 e to the -3. And then we see what that equals. And so I end up getting 2.5 e to the -6. Then I just say, well, hey, does that equal K, which equals 2.4 e to the -5? And I look and I say, does Q, which is this, equal K? No, it does not. So I put a line there. Now I got to think about this. Okay, K is bigger than Q. So Q needs to get larger. All right. So to get Q larger, we need to have our calcium and our sulfate ions to be larger. And so that means it's going to have to shift to the right. Okay, this equilibrium, this KSP up here, it's going to shift to the right because Q needs to get bigger to approach K. So Q does not equal K, so it's going to shift right. And so because it's going to shift right, it's going to make more of the calcium sulfate dissolve, so no precipitate will form. Okay, that's it for this video. See if you can do those two problems.